Okay, here we are, vectors, part one, day number one, on some vector basics. Let's get right into it. Two different types of vector representations. You'll see here, this is column vector representation. An example of column vector representation would be, let's say, 1, -3, 5. What each of the components of this vector representation mean are, this is your x movement, so left and right. This is your y movement, up and down. This is your z movement, which can be interpreted as towards you or away from you. Okay, that's vector column representation. Now this same vector v, let's call it vector v, can be represented in this position vector representation right here. Okay, position vector representation is the same exact meaning, okay, except we throw in this I, j, and k. So what we would have is 1i minus 3j plus 5k. So there's no difference between the two. They mean the exact same thing. They're just two different formats for writing out a vector. Okay, so here's an example. Here's vector A, okay? Vector A over here moves 1, 2, 3, 4 units to the right, and 1, 2, 3 units up. So there's one way to write vector A. Another way to write vector A would be 4i plus 3j. Okay, vector B moves 1, 2, 3, 4, 5 units to the left, 1, 2, 3, 4, 5 units up. So vector B representation would be 5 left, 5 up, which could be written in the other representation in this way, -5i plus 5j. Okay, so let's do a little bit of work with these items. So let me remind myself, A was, I like column vector form of 4, 3, and B was -5, 5. So if I want to take A and B and add them together in part A, I add their coincident components. So what does that mean? I add together the items that would be like. So here I'm going to add 4, 3, and 5, -5, which would give me my vector A plus B, right, which is going to be, oops, I got those flip-flopped. That's -5, that's +5. So that should be a -1 and a +8. Okay, and that would be our answer for part A. That is A plus B. Let's do it again. Let's try a different set of operations here. In the second case, I'm going to take A minus B. I'm not going to do all the math, but 4 minus a -5 would be 9, and 3 minus 5 would be -2. So that would be A minus B. I'll highlight that one for you. Okay, and then now we've got a little scalar multiplication along with what we're doing. So I'm going to take 2 A's and subtract 0.5 B's. Okay, so let's figure out what 2A would equal. Well, A was 4, 3, so 2A will be 8, 6. B was -5, 5, I believe, right? Yeah, -5, 5. So -5, 5 times 1/2 would be -5 halves, 5 halves. And then we just subtract 8 minus a -5 halves would be 21 halves. And 6 minus 5 halves would be 7 halves. Okay, equivalent form, of course, you could do 21 over 2i plus 7 over 2j. Okay, either of those would be acceptable answers. Just basic algebra involved there. So That should be slam dunk. Okay, when finding the magnitude of a vector, the magnitude of a vector is the length of its hypotenuse, or distance, right? If you're two-dimensional, oops, I want to go to a pen here. Let's say you have a two-dimensional vector. Let's say it's xy, right? Let's call this vector r. Let's say it's 3, 4, right? So right 3 up 4. So right 3 up 4. This vector's tail would be here, and the head of the vector would be there. What would be the length of the vector, or what we call the magnitude, right? The magnitude would be 5. So all we do is Pythagorean theorem in order to find the magnitude of a vector. Now, if we go to a three-dimensional vector, I'm going to do my best to sketch this. Let's say we go 2, 3, 4, right? So this was a right angle, and this is a right angle. Okay, so this is moving to the right, away from us, up. Okay, Pythagorean theorem still applies, right? That's still just going to be, you know, whatever x, y, and z are into the Pythagorean theorem. Okay, so we got a three-dimensional example here. What I would do is I'd do the square root. Let's say this is vector A. 2 left, 3 up, and 1 towards you. I don't know, whatever the dimensional analysis on that would be. I'm going to take negative 2 squared, which is 4, plus 3 squared, which is 9, plus negative 1 squared, which is 1. And it looks like that'll be the square root of 14. Yeah? Yeah. Looks good. That's how to find the magnitude of a vector. Okay, the unit vector is a vector in the direction of the given vector of length 1. Why is this important? Because then we can take any vector, turn it into a length of 1, and then in turn multiply it by whatever number we want to make it the length we want. So we can find the unit vector and multiply it by 50 if we want a vector of length 50 in that direction. So let me show you how to do that. This notation right here, a hat, represents the unit vector. And all we do is take the vector itself and divide by the magnitude. And vector divided by magnitude. So what that might look like the previous example, let's take A equal to 3, 4. Right? I'll put it in component form, which would be 3i plus 4j. Magnitude of A, magnitude of A is 5. We use Pythagorean theorem for that. So A hat would equal, in whatever form you want it to be, would be 1/5 times 3, 4, which could be written as 3/5, 4/5, or you could do 1/5. This is the way I typically do it, 3i plus 4j. That would be a unit vector in the direction of vector A. Okay, now here are a couple of different examples of unit vectors. These are very simple unit vectors, but they don't always follow some simple pattern, right? If vector I is 1, 0, right? What does that mean? That means horizontal movement of 1 unit. Oh, well, that was really easy. What would the square root of 1 squared plus 0 squared be? Well, it would equal 1. So the magnitude of vector I was equal to 1. That's pretty straightforward, right? Likewise, j, vector j, if you have 0, 1, that's 0 movement right or left, but 1 in the vertical sense, right? So, of course, Pythagorean theorem, again, would work for that. But what if your vector, right, is not just horizontal or vertical in movement, right? Like A here. Well, A looks to be, what is that, 5, 3? Oh, my goodness. Hello. Okay, there we go. That's the weirdest looking 3 I've drawn today. Okay, so A is 5, 3. So how would I find a unit vector in the direction of A using the formula we know? So A hat would be A over magnitude of A. So the first thing you should do is find the magnitude of A. Okay, so A hat, let's do the magnitude of A. Magnitude of A will be Pythagorean theorem, 3 squared plus 5 squared. Now you're tempted to think that's a Pythagorean triple, but it's not. Okay, that's 9 and 25, which is 34. So unit vectors aren't always going to be pretty. A hat, in this case, is going to be, I don't know, let's just say it's about that long. That vector could be written in this way. It would be the original vector, 5i plus 3j, times 1 over the square root of 34. Okay, so the unit vector is very important. We're going to see an example on the next page of that in just a moment. Okay, so the first thing I want you to do is find magnitude of u, and you might have already done that. You might have paused the video, but I'm going to do it right here. So it'd be the square root of 1 plus 4 plus 1. How'd you get those? I squared each of these. I squared 1, I squared 2, I squared negative 1. And Pythagorean theorem will get me, well, a triple Pythagorean theorem will get me the square root of 6. Okay, so I know the magnitude of u. I like those symbols there, by the way. So I'm going to keep putting them there. Find u hat. Well, u hat is going to be the original vector, u, right, over the magnitude of u. Okay, so let's do that. So the original vector u is I plus 2j minus k times 1 over the square root of 6. Now watch what I'm going to do here. I have already done all the work. I don't have to do a whole lot more. I'm going to duplicate this for the next two problems, and then I'm just going to change one number. And if you already know what that is, good for you. If you don't, then get with it. Okay? The only number I'm going to change here, nothing changes with the direction of the vector. So u stays the same, but I'm going to change this and this. I'm going to change it to a 5, and I'm going to change it to 100. And now I have a vector of 5 units in the direction of u and a vector of 100 units in that same direction. Okay, that, I believe, is it. Yes, it is. Some little boy got tipped upside down in his Tinker toy box. Hopefully this goes well for you. This should be a review. Like, subscribe, comment below. Enjoy your weekend.